Okay, question 12 is a little bit tricky, so please pay attention. For question 12, right, we can see that the rate equation is first order with respect to the ester and first order with respect to the acid, and the acid is a catalyst. How do you know? Because its concentration was constant, right? So I have an ester, I have an acid. Now, in the first experiment, the ester was 0.2 and the acid was 0.1. And the half-life of with respect to ester is 62 minutes. Now, the next experiment, look, the next experiment, the ester did not change. The acid was doubled, right? So the half-life is constant with respect to ester. Is constant with respect to ester because it was first order. So that means if you change the ester concentration, half-life should not change. But if you look at this example, we are not changing the ester concentration. We are changing the acid concentration. So if you double the acid concentration and the reaction is also first order with respect to acid, we expect the rate to double. And because the rate doubles, so the half-life with respect to ester changes. Okay, so the half-life with respect to ester changing is not because ester concentration changes, because it's first order. So with respect to the ester, so the half-life with respect to ester should be constant, even if ester changes. But now the case is it's not ester that is changing, it's the acid that is changing. This half-life with respect to ester is constant for the ester if you change the concentration of ester. So regardless of whether the ester concentration is 0.4 and acid 0.1, it will be 62. If ester concentration is 0.1, acid 0.1 is still 62. Okay, but now in this case, ester is constant, but you are changing acid. And acid is first order. So it speeds up the reaction. And because of the speeding up of reaction, the half-life of the ester should be half. So it should be 31. Okay, it's a bit complicated. So I illustrate a bit later. So it should be faster now. So half-life is 31. But it will stay constant at 31. As long as acid doesn't change. So let me show you. So that means if acid is 0.2, I didn't change acid, but I changed ester. What will be the half-life? It will be 31. If I don't change the acid and I decrease the ester, its half-life will still be 31. Okay, same for the 62 case. So look back at the 62 case. If I did not change the acid, but I changed the ester to 0.4, the time will be 62 for half-life with respect to ester. So if I did not change the acid and I reduce the ester from 0.2 to 0.1, the half-life will still be 62. Okay, I hope you get it. Look at the table. So basically, if this is 62, it always stays 62 as long as acid is 0.1, because the half-life of ester will not change when concentration of ester changes. So as long as acid still keeps as 0.1, your ester changes to 0.4 or 0.1, it's still the same constant half-life. But in this question, what happened was ester did not change, but acid was doubled. So the rate will be faster since it's first order with respect to acid. So the half-life should be shorter. So for this set of experiment, as long as you use 0.2 as an acid, regardless of how you change ester, it will be 31 minutes. Constant half-life for ester, 31 minutes, as long as acid is constant. Okay, so therefore, half-life of ethyl ethanoate remains at 62 is wrong. Okay, because acid has changed. The graph of rate against ethyl ethanoate is linear. So if I plot rate against ester, it should be linear since it's first order with respect to ester. So therefore, answer is C.